So for problem number 39, just wanted to give you a heads up on maybe you had some trouble with it, maybe you did not, but maybe you want a second look at the lesson. So I just wanted to go ahead and write down the row operations, what you're allowed to do with any matrix, so solving systems of linear equations using matrices. And I kind of thought maybe this little visual would help you. So the diagonal, when we get our system in a matrix form, the first thing we want to do is understand that the diagonal are all those entries in the matrix that go from the top left to the bottom right on the left side of that vertical line. And then the first thing we want to do is get zeros below that diagonal, starting from left to right. So starting with the first column, we want to get zeros there. And then if we have a second column, to get zeros in, we want to get zeros there as well. And just keep moving left to right and get zeros below the diagonal. Once you do that, then you backfill those values to find the values of the variables. So we'll get to that, but first thing we want to do is take our system of linear equations and rewrite it using a matrix. So we just peel off the coefficients of the x and y. To the right side of the equal sign, we have a -2. And then the second equation has a 3 and a 2, and then a 3. So coefficients, and then the right side of the equal sign are the constants. So we have our matrix. First thing I recognize is all the values in this first row are even. So I want to go ahead and divide the first row by 2. So let me pick a good color here. My new row 1 is going to equal the current row 1 divided by 2. So to get from the first matrix to the second one, we're just going to take the first row and divide every entry by 2. So 2 divided by 2 is 1. -4 divided by 2 is -2. -2 divided by -2 is, -2 divided by +2 is -1. I froze there for a second. And then we will rewrite our second row. So that's how we get from the first matrix to the second one. We're allowed to interchange any two rows. We're allowed to replace a row by a multiple of that row, not 0. So that's exactly what we did. We multiply the row by 1/2, or we could think about that as dividing by 2. And then for the next thing we want to do, remember we have our diagonal. Our diagonal is right here. So all we need to do is get a 0 right there. How do we do that? Well, we're going to take, we're going to multiply, let's say, row 1 by -3. So our new row 2 is going to be equal to -3 times row 1. And what I want to show you is kind of a new way of writing this, plus row 2. So if I take -3 and multiply it by row 1, so I can have these numbers right in front of me, we get our new row would be -3, -3 times -2 is +6, -3 times -1 is +3. So that's -3 times row 1. We're not going to change row 1, we're just going to multiply it by -3 and then add it to row 2, and that becomes our new row 2. So now again, our row 2 currently is 3, 2, 3. And when we add these together, we get our new row 2. And a new row 2 would be 0, 8, and 6. Okay, this is one of the examples we did in class. And so then we rewrite our matrix, keeping our first row because we didn't want to change that. We have a nice number there, 1 in the first top left position. And then our new row 2 is 0, 8, and 6. And what we could notice here is that we've got 2 even numbers, but that's not really going to hurt us right now because we're going to have to go ahead and solve for the variable. And again, we have, let's do that first. Let's just go ahead and rewrite this matrix now, introducing the variables back in. So we have the first row means that 1 times x minus 2 times y is equal to -1. And then the second row, 0 times x, we're going to leave that out, plus 8 times y is equal to 6. So now we have a reduced This is kind of like row echelon form, but nevertheless, we have a reduced matrix, and so we're down to one equation with one unknown here on the bottom, so we can go ahead and solve for that. We're going to go ahead and divide both sides by 8, and 6 divided by 8 can be reduced, dividing both top and bottom by 2, so we get 3/4. Okay, so we have our value for y. And this is what I mean by backfill. So we start with the bottom, that's what it says over here. So start right here. We have one coefficient times our last variable, in this case y. Our one coefficient 8 times y is equal to the number on the right side, that's 6. So 8y equals 6, solving for y, we get 3/4. Then we take the 3/4 and we go back one row to solve for the other variable. And the other equation was 1x, so just x, minus 2 times y, which is 3/4, is equal to -1. So now we use this equation to solve for x. And we can notice here, we're going to go ahead and cancel that. So we have x minus 3/2 is equal to -1. Adding 3/2 to both sides, we get 3/2 minus 1 is equal to x. Now 1 is 2 over 2, so 3/2 minus 2/2 is 1/2. So x is equal to 1/2. If you want to write it as an ordered pair, you could do that. And the ordered pair would be 1/2, comma, 3/4. So thinking about this, what this means on the big scale here, we've got two linear equations. So just kind of reviewing what we just did, we have two linear equations. Each of the linear equations, if you graph each equation, you'd come up with a line. So you have two lines, okay? So whatever they are, two lines. And then we go through all of this, all these row operations, solving the system of linear equations using matrices. We get an ordered pair, which is the solution, because this ordered pair makes both equations true, but graphically, that's the place, it's the point where the two lines cross. So the two lines cross at 1/2, comma, 3/4. Okay? So that's, in a nutshell, how to solve a 2x2 or a system of two equations with two unknowns using matrices.